All right, section 14.2 is area. Specifically in 14.1, we were looking at lengths of things, right? Linear measure. And now we're going to look at area, which is going to be the space inside objects. In particular, we're going to look at areas of polygons and of circles. So to start with, first, sort of a loose definition of area is the number of non-overlapping squares of a particular size that cover a region. Area is measured using square units. That's why you see the word square feet or square inches or square centimeters, is because we're measuring squares, literally. Now, this is an example of a square, obviously, and if you take a look at it, if we call this side length 1 unit and this side length 1 unit, then what we reference the area to be is 1 unit squared. So 1 square unit is a square that has side lengths of 1. And that's how we're going to measure all of our areas. And that works great when you have a square or rectangular region like the following. So what is the area of the square grid? So the question is actually asking you if each one of these boxes has 1 square unit, and you count them up, how many square units does this particular picture have? There are 9 units squared. And we say square units, we write it as units squared. Okay? So I'm using UN for units because it doesn't have any other measurement length that we're using instead. So we're going to see UN squared. And literally, what we really did here is we counted, okay? We didn't use any formulas yet. We will, but not yet. Geo Boards. Have you guys used a Geo Board before? Okay. If you haven't, I'm sure you've at least used dot paper before, and they're a very similar object. A geoboard or dot paper can help us to think about area. I don't have any geoboards. That's probably something we should invest in here. But we can use dot paper really easily and also visually here. And I'm going to do an example of one here in a minute, but I'm going to do this first with the addition method. So the addition method is where the area is found by adding the areas of smaller pieces. Okay, so we're going to do much like we did over here. We're going to count up boxes that are inside of an object. It's the addition method. So here's an example. So what we're going to do is we're going to create squares of the shaded region. So we have this square, 2, there's 3, 4, 5, 6, 7, 8, 9. We're only counting whole squares at the moment. 10, 11, 12, 13, 14, 15, 16, and 17. So whole squares, I have 17. So everybody get 17 when you counted through those? And then I've got some pieces that are halves of squares, right? So in particular, this piece right here, you know what, let me mark it like this. This piece right here, this piece right here, this piece right here, and this piece right here. Those 4 pieces are half squares. So if I have 4 half squares, that would be 2 whole squares. And was my number 17 before? Yes? So I have 17 plus 2, so this would be 19 units squared. And a grid like this is super helpful because I can actually physically draw in all my squares if I need to. A child could too, of course, right? You could draw in them all and you could just count them. There's no formulas we're using still yet. Now, there is a benefit to this particular picture that not all pictures have. They are all either whole or half squares, aren't they? And of course, there's ways of drawing things that don't give me whole and half squares. So what do we do then? Well, there's another method besides the addition method, and it's called the rectangle method. So what the rectangle method does is you construct a rectangle around the given shape, and then you subtract off the area that's not actually shaded within inside of your rectangle. And this method is particularly useful when the shape has very few squares that are full inside of it. So this one had lots of full squares. There was no need to draw a rectangle around and to take off the extra white, blank spaces on the outside. But this picture does not have very many filled in squares. It's not shaded on the inside, but I suspect you can look. In fact, it doesn't have any completely full squares, does it? It doesn't. But if we create a rectangle around our object, I would have this one. And if you were to count, how many squares are there inside of the rectangle that I've created? There are 12. And what we're going to do is we're going to take that 12 and we're going to subtract off the full squares we can make and any of the partials that we're going to come up with as we work. So what I'm counting now is I'm counting the pieces that are not inside of the blue. So here's 1, 2, 3, 4. There are 4 full pieces that are not inside of my shape, right? So I'm definitely going to take off 4 of them. And then our goal after that is to find as best we can what we have left over. And we're going to do that by looking at some symmetry, really. And so we're going to try, as we take a look at the symmetry that we have here, and approximate what's not inside. So, for example, if you take a look at, I don't know, we'll say approximate half triangles. Where do we see approximate half triangles? Well, this one looks like about a half a triangle, right? It's not exact, but it's close. And it looks like maybe if I take that piece and this one down here, that those would pair up to be a whole triangle. Approximately, do you think? It looks like a fair estimate. So we're going to kind of try and pair them out together and see which pieces can sort of be going together to create a whole triangle, or whole rectangle, or square rather. Sorry, square. So this is one of them. I'll change colors for my next one. We'll use pink. So if I take a look at, say, this piece right here, it looks like maybe this one right here might make a whole square. It's close. Okay, we're approximating, but it's close. Let's see, if I have this piece right here, it might look like that this piece right here is awfully close. Maybe not perfect, but close to making another one. The last 2 not full, pieces that I have seem like that if they were combined together, they would make considerably more, don't they? So as we're taking a look at this piece and this piece, I think if we put those together, they might be about 1.5. Does that make sense? They're definitely more than one full square if I tried to combine them. So let's see, I had red, pink, and yellow. Those were 3 full squares, approximately. And then I had the green and blue, which is another 1.5. So I think this is minus the 3 full ones and then minus another 1.5. So what do I get if I take 12 minus the 4, minus the 3, and minus the 1.5? This is an approximation. This isn't even what the answer is on my paper, just so you know. We're approximating. Is it 6.5? Nope, I think 3.5. 3.5? 3.5? So we're estimating that this is about 3.5 units squared. And, we should always put estimation signs when we believe that we have, in fact, gotten an answer that might not be quite perfect. It's approximation.
Okay, where'd you get the 3? I'm so
I counted up the ones that it matched. So like the red one here, that's 1.
Oh, okay.
And then I did those at a time. So I did pink, and then I did the yellow.
Okay, that makes more sense.
Yeah. And then the 1.5's from the green and the blues together, which is definitely more than 1. Okay, any questions on that? Yes?
I missed where you got the 12 from.
The 12, we counted up all the squares inside the first dotted rectangle that I made, and there were 12 of them.
Oh, this one.
Yeah, the big dotted rectangle, which it doesn't include the part at the bottom down here, right?
Yeah.
Because I didn't put that inside my rectangle. I could have, but there's really no need to. Okay, any questions on that one? All right, a few measurements, and I'll justify where these come from too, although you probably can guess. These are equivalent units of area. So if we have 1 square foot, that's 144 square inches. 1 square yard is 9 square feet. And then 1 square mile, and the values are there, 3,097,600 square yards, 27,878,400 square feet. There's a lot of numbers to write in there. So write those in, and then I can kind of talk about where those numbers are coming from. Okay, so let's imagine, I'll draw the picture for the second one. But let's start with the second one, the yard squared. Let's imagine that we had 1 yard squared. Whoops, I want squares, not circles. Let's try that again. Okay, so 1 yard squared would mean that each side of my square was 1 yard, right? Now I drew the picture the way I drew it on purpose because you guys know the relationship between yards and feet. How many feet are in a yard? 3. And do you see how I've drawn it so that I've actually circled or got 3 on each side of the smaller black squares or gray squares that are in the background? Okay, cool. So if I were to count up, and these are actually individually 1 foot, so this is a 1 foot square now, how many feet are inside of there? Square feet? There's 9. There's 9 smaller boxes inside, right? So that's where this 9 is coming from. And in particular, what's happening, of course, is that we're getting 3 times 3. And the reason that works is because 1 yard is 3 foot, and you're getting it squared because you're doing it twice. Right? That's what squaring means, multiplying something by itself. So when you take 3 times 3, you get 9. So where do you suppose the 144 comes from if you've got that in your mind?
12 inches in a foot.
Yeah, there's 12 inches in a foot, and when I multiply 12 by 12, I get 144. The huge numbers under miles squared are ones that are less common for us. If you'll remember, the yard conversion was, I think, 1,760. The other one's the one that I always remember, 1,760. So if you multiply 1,760 times 1,760, I suspect you're going to get the 3 million number, right? And then the feet conversion is actually 5,280. And if you multiply 5,280 times 5,280, you get the 27 million number. Okay, make sense? Okay. Here are your metric units of measure. And you see also, again, you've got this wonderful fact that we have tens everywhere. Are you okay?
Yeah, my heart beats too fast and then I can't breathe.
Okay. Okay, go feel better. So we have powers of 10 everywhere, right? Let me just look at the ones that are most nearly related to around here because they're the smallest ones to talk through. So if let me try that one more time. Here we go. If you take a look and if you'll remember, if you did linear measurements, this would be 10 and this one would be 0.1. And if you multiply 10 times 10, of course, you get 100. And if you multiply 0.1 times 0.1, you get 0.01. So it just doubles the conversion every time, just like with the others. It's just that it's because it's doing it with base 10s, all of the numbers are still base 10 numbers. So we have square kilometers, square hectometers, square decameters, and so forth all the way down. And we have these powers of 10 to the side. You know, this one has a lot of writing, so. Okay, does everybody have them all? Excellent. We're going to do a couple of examples of conversions. I'm going to actually show you 2 ways to do the conversions. It's wonderful that we've got these units in here, and that's fine, and you can use them. But I'd like to also show you how you can use your linear measurements to do it that way, because then you don't have to kind of remember as much information or take up as much space on your note card to write them down. So let's take a look at what you would do to convert 300 square feet into square yards. So the most direct way would be to take our 3,000, did I say 300 a minute ago? Sorry. Our 3,000 square feet, and to use the relationship that says that when I have feet squared and I have yards squared, square feet and square yards, that it's 1 square yard is 9 square feet. That's the most direct conversion that uses the information on this slide directly, okay? So if we do that, we would take the 3,000, we would divide it by 9, and we'd end up with what? 333 and 1/3. If you want to use decimals, you can do 0.3 repeating. That's okay. But this would be our yards squared. So obviously that works. I have no problem with doing it that way. This is not how I think about it though. Let me show you how I think about it, just so that you have another option if you like it, and if you don't like it, then that's cool. So when I take things from feet or from square units into something else, I still remember the relationship between feet and yards, because that's just a relationship I know. It's 3 feet, 1 yard. Okay? But then I just square everything. That's how I'm going to get my feet squared to cancel. So this is going to cancel, this is going to cancel, and it means that I'm going to square each of these values inside. So I have the 1 squared and I have the 3 squared. So there's the 9. You don't have to like it, but it's another way to think about it. It's just a squaring relationship.
So you're just squaring everything in?
Exactly. Yeah. And either way you do it, of course, like we've said, you're going to get 333 either 0.3 repeating yards, square yards, or you can do 1/3 square yards. Okay? This next one down here, again, I'll show you the way that you can do it most directly if you have this access to this table and you want to remember the details about square units. We have 378. And if you want to use that table, what that's actually telling you, whoops, is that I can take the kilometers and I can go into meters and then I can go into centimeters, right? Because that's moving across the table. Right, so this is the KH, King Henry died by drinking chocolate milk business. And if I'm going across the table, I can actually count. But if you'll notice, you have to count and you have to double everything. To move anywhere in terms of area on this table, you have to move the decimal point 2 places. Right? That's what this piece of paper or this slide tells us. Is that, for instance, to go from the base unit into decimeters or decameters squared like this, that should say base unit squared, then what we have to do is we have to multiply by the value twice, right? 10 times 10 instead of just 110. You move the decimal 2 times instead of 1 time. So what I would do is I would count. So to go from K to CM, how many places is that? It's 5, right? It's 5 decimal places to the right. But because we're doing square units, how many decimal places are we going to actually move the decimal? 10. We are going to move it 10. So 378 already has the decimal point at the end, which means to move the decimal point 10 places means to add 10 zeros. Then we got to count backwards and see if we've got the right number. I think we've got a 3 and then 7, 8, 0, and then followed by 9 more zeros. That would be 3,780,000,000,000. That's the number. Units? Centimeters squared. Okay, so we're moving the decimal point double the amount of times that we would have if we were doing linear measurements. Okay, let me do one more set and then we will pause and we'll take a look at some group work. Measuring land area. There are English units that are called acres. Who's heard of acres? Okay. Has anybody heard of the TV show Green Acres? Okay. Some Nick shaking heads no. You're making me feel old, Jessica. Thanks so much. Green Acres. TV Land, that's right. And I think that's the only place I've seen it too, actually. It is very old. So that's acres. There is no abbreviation for acres. Sorry, you're just going to write out acres. It's a whole 4 letters. I think we can handle it. We also use square miles, and we do that, right? We do that. And then metric units are air, and it's A-R-E, but it said air, and it does have an abbreviation A. Hectare, which is H-A, and square kilometers, which is km squared. And these are some conversions between the units of area. 1 acre is 100 meters squared. 1 hectare is 100 acre or 10,000 meters squared. 1 kilometer squared is 100 hectare or 1,000 meters squared. So we see all those powers of tens and everything. And then you'll notice the last two, so these first three are your metric ones, right? These are all metric. And the bottom two are the English ones. 1 acre is 4,840 square yards, and 1 square mile is 640 acres. And we really don't like English measurements anymore, right? Especially when we get to this point, I am not a fan, because I do not want to remember all of these things that are not powers of 10. That makes it much more difficult. And since I'm not a farmer, I'm not truly ingrained in the whole how big is an acre business either. Sorry. Okay, so we're going to do a couple of examples of these, and then we'll call it good for today. A square field has a side that is 30 meters. We're going to find the area in hectares. Okay, so we have 30 meters. And we need a conversion that takes meters. I'm sorry, let me take one more side. We have a side length. The side is 30. We need to first find the area. We didn't even do that yet. So what's the area if we have a field that has sides 30 meters? Yeah, so our area would be 900 square meters, right? Okay, that's where we're going to start. So we have our 900 square meters. And we need a relationship between square meters and hectare. And I think that's actually in our table, isn't it?
How did you get 900?
Because a square is 30 on one side and 30 on the other side.
Oh, okay.
Yeah, because it's because it says square field.
Okay, that makes sense.
Yep. Okay, what is the relationship between square meters and hectare?
10,000 square meters is 1 hectare.
Right, 10,000 square meters is 1 hectare. And the reality is that if we're dividing by a power of 10 that has 4 zeros, that's the effect of moving the place value 4 to the left. And if you're not sure and you don't like what I just said, that's cool. You've got a calculator, right? You can grab your calculator, and you would take the 900 divided by 10,000. And we will end up getting the hectare because we, on purpose, chose the meters squared as our conversion ratio. So what do we get when we take 900 divided by 10,000? 0.09 is correct. 0.09 hectare, H-A. No, hectare, that's a great question, Madison. I'm glad you said that. Do notice that these units don't all have squares on them. In particular, this one right here, acre and hectare, they are not square units. I mean, they are square units, but they don't actually have them written in terms of something squared. They are standalones. And the same is true for acre. 1 acre is already a square unit measurement.
Is there a reason for that, or is it just?
Because it's measuring the distance and the space inside. That's all. It's just actually a measurement that only measures area instead. Whereas like meters, say for instance, is a measurement of length, and then when you multiply length times length, it gives you the square part of it. Yeah. Okay, one more example for today. We have a square field that is now 0.3 miles. So again, square field, side length 0.3 miles. So the first thing that we need to do is to find the area. What will the area be for our square? All right, so we'd have 0.3 times 0.3, which is 0.09 or 0.09 square miles. Make sure when you're doing miles, you do MI for miles and not just M for meters. Okay, and then our relationship is to take that 0.09 square miles and to multiply it by the relationship between square miles and yards, or sorry, feet. Now, again, if you want to use the direct comparison they give you, which is that 27 million number, you can. The number that I remember is it's 5280. I'm sorry.
Is
Did it want it in yards? I'm sorry, I looked at it wrong. Thank you. Into yards. Okay, so the number between the miles and the yards is 1760. There are 1760 yards in 1 mile, but I want them squared so I can square all the values. Again, you don't have to do it this way. The other option would be to take the 0.09 miles squared. I keep doing that, leaving my eye off. Oh my goodness, what's the measurement? It's huge. 3,097,600 yards. Okay, so you can do it one of those two ways. Either way, you will get the same answer
Did you get the 1760?
from last section, 17 or
Oh,
14.1. It's a relationship.
Okay.
Yep,
Okay. I just wasn't directly looking at it, so I think that's why I didn't know.
that's okay.
And so you would divide that by 0.09?
Nope.
Divide.
Everything's multiplied here because the only thing in the denominator is a 1. The numerator has all the other non-1 values in it. So you're going to have 0.09 times the 3,097,600 or times the 1760 twice. 1760, 1760. Either way, you get the same answer. What is the answer you get? That sounds right to me.
I did a little different.
What did you do?
Like 2 steps.
Okay.
I went from square miles to acres and then acres to yards.
Yes, you can do that too. So if you use this relationship here, you can go from miles into acres, 640, and then acres into yards. There's often more than one way of doing these because they get more complicated with the
I
conversions.
did it kind of like the stoichiometry way that you do it.
Yep, and we did it last time. It's called dimensional analysis. Yep.